We experience time every day. It's a constant presence in our lives, ticking away second by second. We see it in the changing seasons, as nature cycles through birth, growth, decay, and rebirth. We feel it in the aging process as we grow older and our bodies change. But what if I told you that time may not be what we think it is? What if our perception of time is just a construct of our minds? What if time is not a straight line from past to future, but something far more complex? What if it's more like a winding river, with eddies and currents that can flow in multiple directions? Our everyday experience suggests that time flows in one direction, from the past to the present and into the future. We remember the past, but not the future. Our memories anchor us to a linear timeline. This seems to confirm a linear view of time, where events unfold in a sequential order. However, the laws of physics don't differentiate between past and future. They treat both directions of time equally. This means, theoretically, time could flow in either direction. The past and future might be more interconnected than we realize. So, is time an illusion? Is it merely a byproduct of our consciousness? Or is it a fundamental aspect of the universe, woven into the very fabric of reality? These are questions that have puzzled physicists and philosophers for centuries. The nature of time remains one of the greatest mysteries. To understand time, we need to look beyond our everyday experience. We must delve into the realms of theoretical physics and cosmology. We need to explore the strange and wonderful world of modern physics where time might not be what it seems. Only then can we hope to unravel the true nature of time. Albert Einstein revolutionized our understanding of time with his theory of relativity. Before Einstein, we thought time was constant. Einstein showed that time is actually relative. It depends on your motion. Imagine you are on a spaceship traveling at incredibly high speeds. Time inside your spaceship would slow down relative to someone on Earth. This is called time dilation. The faster you travel, the slower time goes for you. This isn't just a theory. Scientists have measured time dilation using atomic clocks. They flew one clock on a jet plane. They kept another clock stationary on the ground. The clock on the plane ticked slightly slower than the one on Earth. This proved that time is indeed affected by motion. The idea of time travel is a staple of science fiction, but is it actually possible? Einstein's theory of relativity suggests that it might be. One possibility is to create wormholes. These are theoretical shortcuts through space-time. Imagine folding a piece of paper in half. Now imagine poking a hole through both layers. That hole is like a wormhole. It connects two distant points in space and time. If we could create and control wormholes, we could potentially travel through time. Another possibility is to travel faster than the speed of light. However, this presents a significant challenge. As an object approaches the speed of light, its mass increases infinitely. This makes it physically impossible to reach the speed of light, let alone surpass it. Section 4. Mind-blowing time facts. The universe is full of strange and wonderful phenomena that challenge our understanding of time. From the vastness of space to the tiniest particles, time behaves in ways that are both fascinating and perplexing. Take, for example, the concept of time dilation due to gravity. This phenomenon, predicted by Einstein's theory of general relativity, shows how time can be stretched or compressed. Time slows down in stronger gravitational fields. Near a massive object like a black hole, time can almost come to a standstill. This means that time passes slightly slower at sea level than it does on top of a mountain. Even the difference in altitude on Earth can cause measurable changes in the passage of time. Another mind-blowing fact is the existence of cosmic time. This is a universal clock that has been ticking since the dawn of the universe. This is the time since the Big Bang, the colossal explosion that created the universe. It's estimated to be around 13.8 billion years. This timeline helps scientists understand the evolution of the cosmos. However, due to the expansion of the universe, the actual age of the universe could be much older. The stretching of space itself affects our measurements of time. These examples highlight the fact that time is not as simple as we might think. Our everyday experience of time is just a small part of a much larger and more complex picture. It's a complex and mysterious phenomenon that is still not fully understood. As we continue to explore the universe, we may uncover even more astonishing facts about the nature of time. Section 5. Time paradoxes. Time travel also presents us with a number of fascinating paradoxes. These paradoxes challenge our understanding of time and causality, making us question the very fabric of reality. One of the most famous is the grandfather paradox. This paradox is a classic example that has intrigued scientists and philosophers for decades. Imagine you travel back in time and accidentally kill your grandfather before your parent is born. This creates a loop of impossibility. This would mean you would never have been born, so you couldn't have traveled back in time to kill your grandfather. The paradox creates a scenario where your very existence is called into question. Another paradox is the bootstrap paradox. This paradox delves into the origins of information and objects. Imagine you find a copy of Hamlet and travel back in time to meet Shakespeare. You're eager to share this masterpiece with him. You show Shakespeare the play and he copies it down. He then claims it as his own work. The play is then passed down through history, eventually leading to you finding the copy and traveling back in time. This creates a loop where the origin of the play is lost. The question then becomes, who actually wrote Hamlet? Was it Shakespeare or was it you? These paradoxes highlight the potential logical inconsistencies that arise when we consider time travel. They force us to rethink our understanding of cause and effect. They suggest that there may be fundamental laws of physics that prevent us from changing the past. These laws could be nature's way of preserving the consistency of the timeline. As we continue to explore the mysteries of time, these paradoxes remind us of the complexities and wonders of the universe. Section 6 is time and illusion. So we've explored the nature of time, the possibility of time travel, and the paradoxes that arise. But the question remains, is time real, or is it all in our heads? Some physicists believe that time is an emergent property. This means that it arises from a more fundamental, timeless reality. In this view, time is not a fundamental aspect of the universe, it's a consequence of our limited perception. Ultimately, the true nature of time remains a mystery. It's a question that continues to fascinate and challenge us. Perhaps one day, we will unlock the secrets of time. Until then, we can only marvel at its mysteries. Do you think time is real, or is it just something humans created to make sense of the universe? Share your thoughts. If you could travel through time, would you go to the past or the future? Why